Please write today's date and write examples. All right. Now we are going to do a bit of some application now. That is using those theorems to get answers. Okay. So this question, you are given a diagram. Please, I expect everyone to pay attention. So you've got this circle, there's a center here. The center is O. Then there's an angle B at the circumference. And the acute angle at the center is 60 degrees. Right? Right? Obviously, you've got a vertex here and another vertex there. Okay? So we need to determine the value of x. Okay? Now, to determine the value of x, you need to know that we have an angle at the center here, which is acute, and we have got x at the circumference. Right? The two angles are subtended by the same chord AC. Please, the chord is not drawn. So I can call it an invisible chord. Okay? You can construct it if you like. Right? Also, arc AC, this arc here, AC, it subtends the 60-degree angle at the center. It also subtends the x at the circumference. Therefore, angle x is going to be equal to half of acute AOC. Okay? If you want here, you can add acute AOC, because there is also a reflex AOC. But here you are dealing with the acute one, which is 60 degrees. So x is half of AOC. The reason angle at center is equal to 2 times angle at circumference. Okay? The angle at the center is 2 times the angle at the circumference. And remember, the one angle must always be at the center, the other one must be at the circumference, and both angles must be subtended by the same chord or same arc. So we have our statement, then our reason. Right? So x is going to be half times 60 degrees, which gives you 30 degrees. Okay? So that's how you apply. This is a simple case of application of theorem 2. All right? Now, geometry, yes? What? That's an unfortunate. When I spoke about the races out of it was this week. Yes.
We started on Friday.
Yeah, but when did I talk about the web subtend?
On Friday, I think.
Huh?
On Friday, I think. But you did talk about it. Yeah. You gave us an example. On the 7th of March. I don't write dates.
When? On Monday. Yeah, but I know it's not last week. All right. So I'm going to repeat this. Okay? An angle can be subtended, which means the two line segments that form that angle, they will originate from a chord or they'll originate from an arc. So, to make the angle 60 degrees, you start from the circumference here all the way to the center. To make the angle x, you start from the circumference all the way to the circumference. So, both angles are subtended by the same chord, also by the same arc. Okay? That's why the acute angle at the center is 2 times the one at the circumference. That's how we do it. Right, so that's a simple example. Then you can also have another scenario which is not very direct, okay, like the first one, whereby you have got an angle at the center, also you have got an angle at the circumference, okay. Both angles are subtended by the same chord AB. Therefore, angle X is 2 times angle C. Okay? And here we talk about acute, obviously this would be acute A or B. Acute A or B is equal to 2 times C because the angle X is at the center and angle C is at the circumference. Hence, angle C is half of X. Or you can say X is equal to 2 times C. And your reason, angle at center is equal to 2 times angle at circumference. And this reason here, you have to learn to work with it. Okay? So this kind of orientation is a little bit tricky, especially if you get questions where there are other lines. Yes.
So do we always have to specify acute AOC or acute AOB or reflex AOB?
Okay. What I would suggest, this is the way that I will answer that. Be aware that when you've got a case like this, there are 2 angles at the center. There's a reflex, there's an acute. Now, to show that you really understand what's happening, if it is the acute case specified, that it's acute, if it's reflex, also specified. Okay? But generally, there's no mark for that. Okay? There's no mark. As teachers, we are not very strict about putting that word acute or reflex. Okay? But it's just an indication that you understand that the angle at the center is the acute one. You are dealing with the acute one because of the size of C. Okay? Then you give your reason. X is equal to 2 times 10. That gives you 20. So that's another orientation of an angle at the center and one at the circumference. Right? Then you can also have another diagram whereby we have got an acute angle at the center. Then we have got an angle at the circumference. Right? Always ask yourself which chord or which arc subtends those 2 angles. Identify the chord or the arc which subtends both angles. If an angle is at the center, there's another one at the circumference, then you need to identify which chord subtends both angles or which arc subtends both angles. So in this case, it's going to be chord or arc AB. Okay? Chord or arc AB subtends the angle which is equal to 36 degrees at the center, also angle X which is at the circumference. Every time you see an angle at the center, Theorem 2 must click in your head. Ask yourself that maybe, I'm using the word maybe, I need to apply Theorem 2. The moment you see an angle at the center, also if you see an angle at the circumference and the center is clearly identified, and there is an angle at the center which might not be labeled, it could be Theorem 2 that you are supposed to use. Right? So here, BAC, which is again the acute 1. So acute BAC is equal to half A or B. That is A. Okay, sorry, I made a mistake. Please, this is not acute. It's supposed to be the other way. So BAC, that is, this is B. CA, which is X, is equal to half of acute A or B. Okay? And the reason angle at center is equal to 2 times angle at the circumference. Then substitute, so X is going to be half of 36, which is 18 degrees. All right? Any question? Okay. Then you can also have a case where you have got the reflex now. Right now here, angle X, by observation, it's more like it's obtuse. Therefore, it would make more sense to say that angle X is half of reflex AOC. That's why here I wrote ABC is half of reflex AOC. You have to use common sense for a case like this. You can't calculate the obtuse here and say it is 2 times this angle. It won't make sense. Okay? So someone would say 360 minus 230 to get 130, which is an obtuse angle. There is no way that 130 is going to be equivalent to that. So angle X is going to be half of the reflex of AOC. Okay? So you get half times reflex AOC. The reason angle at center is 2 times angle at circumference. Now, both angles, okay, both angles are subtended by the same arc. Okay? So the answer is going to be 115 degrees. Okay? So here I'm showing you some examples in different scenarios for applying theorem 2. Okay? Any questions? So far it's very easy. But later you need to know that these diagrams, you can combine them into questions that require application of more than one theorem. Right? But here we are just starting. Right? Then you can also have some cases where your knowledge of triangles is required. That is, the sum of angles in a triangle adds up to 180 degrees. They are supplementary. Also, exterior angle of a triangle, which is what you did from grade 8. Okay? So here, you are given a line which passes through the center from P on the circumference to R on the circumference. What is the name of that line? Diameter. Then there is an angle at the circumference, which is subtended by the diameter. That's theorem 3. Okay? An angle subtended by a diameter at the circumference is equal to 90 degrees, always. Right? So first thing here, if I want to calculate x, I have to know, or I have to prove that this angle here is 90 degrees. Okay? Yeah. Okay, I need to say this. The grade 11 geometry is very, very important. When you're answering the questions, it's always better to provide more information than less information. Whatever comes into your head, when you see the question, write it down. Don't just do it in the head. Because you never know, maybe what you didn't write may be allocated the mark. So it's always better to provide more information than less information. So here, you cannot be tempted to just start writing angle Q plus P plus I is 180 degrees, then you say Q is 90 degrees. Why are you saying that Q is equal to 90 degrees? Write that down. So, angle Q is 90 degrees because it's an angle in a semicircle. That's theorem 3. Okay? So this will be theorem 3. That's the reason. Once you have that, then you can carry on and use your knowledge of triangle. So in triangle, every time you are dealing with triangles, identify the triangle, name the triangle. So here, in triangle PQR, angle Q plus P plus R, they add up to 180, and the reason, sum of angles in a triangle. When you substitute, you simplify. You get your x as 35 degrees. Okay? If you write everything, your statement, your reason, you're most likely to get full marks. Don't keep anything in the head. Write it down. Okay? So this is the first one. Okay? So every time you see a diameter, theorem 2 must come into your mind. The moment you see that, okay, the person has got a diameter, it means one of the theorems that you are most likely to need is theorem 3. Then for B, again, AC passes through the center, therefore it's a diameter. Okay? Which means this whole angle here is going to be 90 degrees. That is angle ABC. So first, you must state that angle B is 90 degrees. Why? Angle in the same circle. Right? Then we know, okay, we know that if this is 90 degrees, obviously 52 plus x will give me 90 degrees. They are complementary angles. Right? Then you simplify, and then you get the size of x. Okay? So far it's easy. Geometry is easy. Okay? Yeah. Don't surround yourself with people who tell you that geometry is difficult. Can I move on? Yeah. Make sure you know your theory. All right. Any question? Any question? Right, I need to move on. Okay, we did this question. Right? All right. I think, okay, I'll talk about this later.
What was that other one?
Okay, don't worry about this. I'll talk about it under cyclic paths. That's when I'll talk about this. Okay? It's the converse of theorem 4. All right. You can also have a case like this. Well, this diagram, I took it from Platinum Maths. Okay, that's where it is from. Right. My concern is that some of you might not see it properly. But how many of you have got Platinum Maths on the PDF? You should have it on your phones.
I have the physical copy.
Right? Yes. Can I see? You've got the physical copy. But I think one of you sent the Platinum Maths. I think he sent on the group as well. Also, if you go to the link which I sent you from my OneDrive, it's one of the e-books that's there. I hope you have got the textbook as well on your phone. So I just want you to go where this is. All right, we are doing geometry, remember? So page 190, that's where that should be. I just want to tell you where I took it. Right, so I took this from page 196. Right, you should have at least the Mind Action series on your phone, the Platinum Maths on your phone. So it's exercise 2, question 4. That's where I took that. Okay, exercise 2, question 4. Page 196. It's exercise 2, question 4. That's where this question is. All right. Now, for this question here, you need to calculate the sizes of angles, okay? Or the sizes of those letters, right? Now, well, in my case, I'll start with calculating A first, okay? Using Theorem 4. Can you pay attention there? Right? So if I use Theorem 4,